If you're enjoying these videos, subscribe. Let YouTube know that I'm doing a good job by subscribing to the channel. Plus, you'll get notified when I have new videos coming out. And finally, if you're enjoying what I'm doing, give it a like. Just click on that thumbs up, and that way YouTube knows that you like it, and they'll pass it along to other people that might enjoy my content as well. I really appreciate it. Thank you again. Let's get started.
Thank you po, Dr. Edna, for that endearing message to our speakers and to the scientific community. Before I introduce our first speaker, I would like to inform everyone that you may leave your questions or comments in the comment section of this FB Live post. Pakilagay lamang po kanino sa ating tatlong speakers naka-address ang inyong katanungan at saang institusyon kayo nabibilang bago ang inyong mga katanungan o komento. Our resource speakers would be more than willing to answer your questions later. We are also encouraging our participants to give access to StreamYard by clicking on the link on the description box so we can see and show your name during the live broadcast. Also, our open forum will be done after the presentation of the third speaker. All right, magsimula na po tayo. Our first speaker is a professor at the Pampanga Agricultural State University, or PSAU, and is currently the director of the Tamarind R&D Center. He is a Bachelor of Science in Agriculture graduate of PSAU, formerly known as Pampanga Agricultural College. He pursued his Master of Agricultural Studies from the University of Queensland through the Colombo Plan, Australian International Development Assistance Bureau, while he obtained his PhD in Horticulture at the University of the Philippines, Los Baños. He is the program leader of the Tamarind R&D Center, a program under the Niche Centers in the Regions for R&D, or NICER, of DOST's Science for Change program, or S4C. His research interests include production and management and physiology of horticultural crops, including tamarind and tropical science. Ladies and gentlemen, it is my pleasure to give you Dr. Virgillo Gonzales. Hi, Dr.
Hello,
Gonzales. Kumusta po?
Ito, medyo nakapag-recover na kami sa Pampanga kasi maraming nagliparang bubong dito sa Pampanga.
Sige po, sir. Sir, pwede ko po bang malaman kung bakit tamarind po ang napili ninyong commodity para pagtuunan ng pansin, particular na po sa pananaliksik?
Thank you, JN. Good afternoon to everyone. Tamarind is a drought-resistant tree. It is suitable in marginal infertile areas. Di na po kailangan ng chemical spray, di katulad ng mga ibang mga prutas. With tamarind, we'll be hitting 3 targets in one bullet. Para pong kapihan, 3 in 1. Una, livelihood for communities, reforestation of denuded mountains, and at the same time, we address the raw material needs of the tamarind industry. Thank you very much, JN. JN?
Sige sir, hindi ko na po patatagalin at alam ko po na excited na ang mga participants natin ngayon sa inyo. Sige po sir, Dr. Gonzales, go ahead po.
Good afternoon, viewers. Today I'll be discussing about the morphological characters of different tamarind lines as basis for selection and commercialization in accordance with the quality and needs of the country. Take it away. Thank you very much. Isang magandang araw po sa ating mga viewers. Po ay bahagi ng programa ng Department of Science and Technology at saka ng Pampanga State Agricultural University sa ating Sampaloc. Ngayon, bago ko po ibigay yung mga teknolohiya na develop namin dito sa Pampanga State Agricultural University, ang tanong palaging tinatanong, bakit sa Sampaloc? Well, ang puno po ay matibay at hiyang sa tagtuyot. At actually, kailangan po niya yung kakulangan sa tubig para mamulaklak at magkabunga. Ang puno po ng sampalok ay hiyang sa mahinang lupa. Ito po ay trilegium. Ang mga dahon niyang nalalaglag sa lupa ay mataas ang nitrogenol. The tamarind tree could contribute 120 kilograms of nitrogen per hectare per year. Ang sampalok po ay wala pang seryosong mapanirang insekto. So, kasalukuyan, hindi pa kailangan ng pag-spray ng mga chemical, insecticide man o fungicide. Marami din po siyang health benefits para sa kalusugan, pag-iwas sa mga sakit o mga karandahan. Ang puno ay iyang sa mga na pwedeng itanim sa mga nakakalbong bundok, sa mga matuyot na lugar, sa mga mahinang lupa. So, dalawa pong pakinabang dito, dagdag na kita sa mga reforestation areas at pwedeng gamitin po ito bilang reforestation species sa ating mga kabundukan. Ito yung mga concerns issues sa sampalok. Una, ito yung mga tanong yan. What are the quantity requirements and quality standards of processing plants? Ano yung mga pangangailangan ng ating mga small and medium entrepreneurs para sa sour at saka sa sweet tamarind? Ano yung mga suliranin ng ating mga tamarind growers in relation to production and quality of harvest? Ang mahalaga po dito yung quality. Kasi medyo maselan po kung gagamitin as raw material yung sampalok, yung mga bunga sa processing. Pangatlong katanungan po na sasagutin po natin ngayon ay ano yung mga ongoing technology interventions na ginagawa ng aming universidad o pamantasan to address the needs of both tamarind growers and food processors. Ito pong malaking demand ngayon sa sour tamarind. Makikita nyo po sa slide na makikita nyo sa mga retail stores, yung po sinasabi nilang tamarind powder. Isa pong malaking food ingredient company ay umaangkat po siya ng 8,000 tonelada ng sour tamarind raw materials para sa broad processing sa isang taon. Kaya lang ang problema po natin sa Pilipinas, we are only producing 7,436 tons of pods per year base po sa Philippine Statistics Authority. That was in 2015. Ang capacity volume ng mga processing plants, nagpa-process po sila ng mga 5 hanggang 60 tonelada kada araw, umpisa ng October hanggang December. Ano po natin, kung susumahin po natin, kung gagawin nating plantasyon, on a per hectare basis ng ating sour tamarind, malaki po ang pakinabang. Kung ang may-ari ay diretsong itatransport yung mga raw materials o bunga sa mga processing plants kung walang middlemen o walang market intermediaries. Kung sa isang hektarya ay meron pong mga 100 malalaking puno, pwede pong may pakinabang o linis na kita na 143,000 pesos. Ngayon, kung ang gagawin po natin ay non-conventional, yung high density planting na sinasabi nila na magtanim ng maliliit na puno, i-maintain na hindi lumalaki yung mga puno at meron silang dwarfing rootstock or dwarfing rootstock, pwede po tayo makapagtanim ng mga 400 na small trees kada hektarya. And we could get a net income of about mahigit na 200,000 pesos kada hektarya. Ano po yung mga quality standards ng ating mga food processors? Una, kailangan po nila, kung gagawin na ipaprocess na tamarind powder, ang kailangan po yung hindi hinog, mga 5 buwan, pagkatapos mamulaklak, maaari na po siyang pritasin. Dapat po ang kailangan nila mahabang mga bunga, with at least 3 segments or seeds per pod. Yun po ang minimum number of seeds per pod na ina-accept ng ating mga processing plants. It should be free from breakage, hindi tinatanggap po, reject yung mga nabubulok, may molds, at may insect and disease damage. Nice ko lang pong i-share sa inyo itong nakita namin pagkakaiba using morphological protocol. Ito pong sa kaliwa makikita nyo, ito po yung bulaklak ng sour tamarind, at dun sa kanan, ito po yung sweet. May pagkakaiba po yung mga petals nila at saka yung mga flower buds. Kapag sour po, makikita po ninyo na yung kanilang flower buds, yung pong hindi pa nakabuka, ay may mga reddish pigmentation. May pagka-orange yung petals na may pula, na malaki po ang distinction kung ikukumpara sa ating sweet tamarind. Ito pong sweet tamarind natin, tignan nyo po yung kanilang flower buds. Makikita po ninyo na yung flower buds walang kulay na reddish. At ang kanyang petals, makikita po ninyo ay pinky. So ito pong nakikita naming pakakaiba in terms of morphological characteristics ng mga florets ng ating tamarind. Sa ating pong mga dugtong na clones o grafted seedlings, makikita po na namumulak-bulak po sila kahit na nasa plastic bag. At ma-distinguish na natin ngayon sa pamamagitan ng pagtingin sa bulaklak kung sour siya at saka sweet tamarind. Ang nakita po namin, pare pong yung between sweet and sour tamarind, may pagkakaiba sa mga petals. Pwede po silang magkaiba kung gagamitin natin ang morphological characterization. Pero ganun pa rin, may mga ginagawa din po kami ngayon, yung genomics, at ibabase dun sa yung molecular characteristics ng mga maasim versus dun sa matamis na sampalok. May mga ginawa din po kami na pag-aaral o pag-evaluate ng ibang lahi ng sampalok. Ang unang karakter na tinignan po namin ay yung kakapalan ng balat. At pangalawa, yung pong porsyento ng pulp sa isang pod. Dapat po kasi para matumaas yung processing recovery, mas malaki ang porsyento sana ng lahi ng sampalok yung mismong laman niya. So titignan po natin dito, tulad nito, isang malaking problema ng ating mga nag-aalaga ng sampalok ay maninipis po ang balat ng mga hinog na sampalok. Makikita po ninyo dito na tulad po nitong isang line na to na PAC sour 1, dahil manipis ang kanyang balat, marami pong breakage. At isa pa pong problema, lalo na kapag ang paghinog niya ay nag-coincide sa tagulan, pwede pong magkaroon ng white molds at nare-reject po yan sa pulp production. Ngayon, kung makapal naman po yung balat, makikita tulad nitong PAC sour tree, makikita no, kaunti ang porsyento ng mga bunga na napitas na may breakage. Nais ko lang pong liwanagin na yung shell thickness is a minor consideration dun sa mga unripe pods for powder processing. Pero ito po'y mahalaga sa mga hinog na bunga for sour pulp processing at saka po yung sa ating sweet tamarind. Makikita nyo dito sa slide na iba't iba ang kapal ng balat ng mga iba't ibang lahi ng maasim na sampalok. Tulad dito, may nakita po kami isang line o selection na mas makapal, higit na makapal ang balat niya kasi mga ibang lahi o lines ng sour tamarind. Ngayon, kung hindi natin sa alang-alang ang kakapalan ng balat, yung tinitignan din po ng mga processors itong porsyento ng pulp or yung pulp to pod ratio na sinasabi nga natin, pinakamarami po, mataas ang porsyento ng pulp sa bunga ng PAC sour 2. Sa mga matatamis naman po, makikita nyo na ang ating aglibot sweet na registered variety sa NSIC ay pinaka manipis ang balat. So nagkakaproblema po tayo, lalo na pag umulan during the month of December, tsaka January, yung pong panahon ng paghinog ng ating sweet tamarind. May nakita na po kami na yung pong isang line dito, introduced variety mula sa ibang bansa na makapal po yung kanyang balat. Ano po ang implication ng shell thickness dito, lalo na kapag pinitas ang mga bunga na hinog? Matibay po yung makapal yung balat sa harvesting. Walang masyadong breakage pag makapal yung balat niya. Pangalawa, pag naulanan po, hindi siya kagad nakakaroon ng white molds. Kapag nagkaroon po ng white molds yung pulp ng hinog na matamis na sampalok, nare-reject po sa mga consumer. Ito naman po ay yung ang hinahanap po ng ating processors, dapat po mahaba yung mga bunga. Makikita po natin na mas maraming porsyento ng mga bunga na mahaba sa PAC sour 2 at malalaki yung kanyang bunga kung pag-usapan natin ay ang hinggil sa mga maasim na sampalok. So ito po, may nakita po kaming isang lahi ng sampalok na magandang quality dahil marami sa mga porsyento ng mga bunga ang mahaba at malalaki po yung kanyang mga bunga. Sa atin naman pong sweet tamarind, ito pong golden sweet na na-introduce sa ating bansa ay malaking porsyento po, mga 90% po ng mga bunga na napitas ay mahaba po siya. At higit na pinakamalaki ang average na size ng mga bunga kung ikukumpara sa mga ibang sweet tamarind lines. Meron na po din po kaming, dahil bawal po kasi ang pag-spray ng synthetic chemicals, pinag-aralan din po namin ang paggamit ng mga biological control agents laban sa mga sakit ng sampalok. Dalawa pong nakita namin, ito pong Trichoderma harzianum, which has found effective against Podospera, yung Saposarium at saka yung Aspergillus niger. Isa naman pong nakita na, ito pong Trichoderma viridae is a potential bioconagent against Fusarium species. na isa ring sakit na nakikita natin sa mga sampalok na puno natin. Isa rin po sa ating nagiging suliranin ng ating mga manananim na sampalok ay ang gastos actually sa pagpipitas. Makikita po ninyo sa slide na habang tumataas po yung puno, nararagdagan po ang gastos sa pagpipitas. Tulad po nito, kung less than 4 meters, yung taas ng puno, ang gastos lang po sa picking ay 2 piso. Ngayon, kung ang puno ay may taas na 9 na metro, makikita po natin na pwedeng umabot sa 9 pesos ang gasto sa pagpipitas kada kilo. Sa mga survey na ginawa po ng mga kasama natin, kanina Dr. Emelita Pempis, kasama po si Al Muñoz, sa sour po ang gastos ay pwedeng umabot ng an average of 6 pesos and 86 centavos per kilo. Yung pong pag-harvest sa sweet tamarind ay arawan naman po, lilitaw na ang gastos ay 417 pesos per day. So yan po ang ating nagiging problema, lalo na kapag ang mga puno natin ay napakataas. Hindi naman lahat po ng lugar ay maraming skilled climbers. So ang ginawa po natin, in-evaluate po natin ang mga iba't ibang lahi bilang interstock. Pag sinabi po natin interstock, yun po yung nasa gitna, na dugtong na mga punla, yung sa ilalim po ay rootstock, yung sa gitna interstock, at saka yung nasa taas ay sayon. So iba't ibang interstock po ngayon ang ginamit namin in-evaluate with the ultimate aim of reducing the tree height and to reduce the harvesting cost para po makapagtanim ng maraming maliliit na puno sa isang hektarya. Po'y nagpapasalamat kami po sa Pampanga State Agricultural University sa pagtulong at sa aming kaantabay yung ating Department of Science and Technology sa pamamagitan ng Philippine Council for Agriculture, Aquatic and Natural Resources, Research and Development, o yung PICARD po. Kami po ay nagagalak at naging kapartner po natin ng ating DOST at PICARD sa pagtulong sa amin na mapalaganap ang teknolohiya at maparami ang ating mga tanim na sampalok dito sa Pilipinas. Yun lang po at maraming salamat po.
Thank you po, Dr. Gonzales. Sigurado po akong maasim at masarap ang sinigang na gawa sa Pampanga. At alam ko po na di rin kayo nauubusan ng matamis na sampalok candy. To the participants, babalik po si Dr. Gonzales mamaya sa open forum po natin. Now, before we move on, I would like to remind our participants that we will choose the questions that will be asked to our speakers, since we cannot attend to all of your questions. But we will try to answer your questions directly in the comment section if they will not be chosen during this session. Alam ko na excited na din kayo sa ating sunod na speaker, kaya hindi ko na ito patatagalin pa. Our next speaker is from Camiling Tarlac, and she is a PhD holder in agricultural science, major in plant pathology. She is the current director of the Root Crops Research and Training Center, Tissue Culture and Research Indexing Laboratory. Her primary interests and field of specialization include plant pathology, tissue culture, pest management, and plant nutrition. We are all very pleased to have Dr. Lilibeth Laranang here this afternoon to discuss the optimization of sweet potato clean planting materials.
Wala. May pumasok.
Hi, Dr. Beth. Good afternoon po.
Hi, hello. Hello, JN. Good afternoon.
Ma'am, same question po. Bakit po kamote ang napili ninyong gawing focus ng inyong research and development efforts dyan sa TAU?
Bakit kamote?
Yes,
Dahil
ma'am.
ang kamote, unang-una, yun yung commodity thrust ng Tarlac Agricultural University. Dahil ang kamote is an important cash crop dito sa Central Luzon. And it is now considered as a superfood by the World Health Organization. Now, the demand for sweet potato in Central Luzon and in other regions is very high, especially for food and the feed industry. So with the NICER program, we want to focus on increasing productivity. Wow, nagawala. Gusto namin ma-increase yung productivity ng kamote dahil we want to increase the production. We want to yung matugunan namin yung supply na kinakailangan ng mga processors.
Sige po, ma'am. For sure, madami kaming matututuhan ngayon sa inyo at alam ko po na may explain nyo sa amin at sa mga participants ang kahalagahan ng ating teknolohiya sa kamote. Ma'am, I won't keep you for long as I am sure that all our participants are now very eager to hear from you. Go ahead, Dr. Beth.
Thank you, Jen, for that very kind introduction. Which is about Project 1 of our Sweet Potato NICER program titled Optimization of SPCPM Production in Central Luzon. Thank you.
Good afternoon, everyone. I'm going to present our ongoing project entitled Optimization of SPCPM Production in Central Luzon. SPCPM, or Sweet Potato Clean Planting Material. This project is part of the Sweet Potato R&D NICER program of Tarlac Agricultural University that is started in October 2019 and hopefully will be completed by September 2021. Working with us in this 2-year project is a Balik scientist, Dr. Narceo Bahit. Central Luzon is the top 3 sweet potato producing region in the Philippines with almost 6,000 hectares planted with sweet potato. 74.97% of this is located in Tarlac. It has the largest commercial production area in the Philippines with more than 5,000 farming households depending on it. Production and processing of dried sweet potato chips for aqua and animal feed is a multi-million peso industry utilizing non-marketable storage routes. Central Luzon is also the source of sweet potato for the fresh market in Metro Manila and nearby provinces for sweet potato fries and other sweet potato-based food products, including the gluten-free sweet potato flour. Presented in this slide are the varieties of sweet potato commercially grown in the region with their corresponding uses. Top on the list is VSP6, locally known as Super Bureau. Area planted to sweet potato in the region used to be as large as 10,000 hectares in the 90s, but the area is declining following the same trend in the national level, which is attributed by farmers to high incidence of insect pests and diseases, the scarcity of good quality planting materials, and drought due to climate change. Pointed out to be the most important biological constraint in the production of sweet potato in the region is the incidence of insect pests and diseases. There are 10 sweet potato viruses that affect the crop either singly or in combination. Most serious is the synergy between the sweet potato feathering mottle virus and the chlorotic stent virus, causing the sweet potato virus disease complex, locally known as kulot. Incidence ranges from 25 to 70%, causing a yield loss of 50% or more. At the moment, there is no variety identified to be resistant to the disease. Apart from viruses, sweet potato weevil was likewise identified to cause significant losses. And like virus diseases, no variety has ever been found to exhibit absolute resistance to the pest. This insect pest can likewise be carried to other places for movement of infested planting materials. Due to insufficient supply of good quality planting materials, farmers are compelled to use vines from previous harvests that may be infected with virus diseases, thus contributing to the perpetuation of the disease. Research efforts have been done towards the control of virus diseases, and so far the use of clean planting materials was proven to be most effective and successful method to manage the disease. Since the use of clean planting materials poses a great impact in the yield of sweet potato, there is a need to optimize its production for science and technology-based interventions to address its increasing demand. Hence, with this nicer project, we need to enhance the production of sweet potato for the use of certified clean planting materials. Specifically, we would like to ensure that the mother plants that we distribute are devoid of the viruses by employing polyphasic assay methods or indexing protocols. To increase the number of clean plants that will be recovered from a single mother plant for a more efficient and effective micropropagation technique. To increase the number of clean harvestable vines through improved horticultural practices. To enable sweet potato farmers and local institutions on SPCPM production and to assist them toward the accreditation of their nurseries and accreditation of their planting materials. In this project, we identify the viruses attacking sweet potato in Central Luzon, optimize the protocol on SPCPM production, and conduct tracer study on the production and utilization of SPCPM. Survey on incidence of virus diseases were recorded during the dry season planting of 2019 to 2020 in 4 major sweet potato producing municipalities of Tarlac, 1 in Zambales, and 2 in Bataan to gather baseline data on incidence of virus diseases. Incidence ranges from 6% in Bataan, 29% in Zambales, and 65% in Tarlac. Based on visual assessment of disease symptoms in each site visited, putative symptoms of virus diseases were observed and documented in sweet potato viruses such as Taiwan, Inube, Kinerots, and VSP6. Common symptoms were intraveinal sclerosis, vein clearing, mosaic, mottling, sclerotic spots, leaf distortion on young leaves, and stunting. This slide shows sample collections of infected plants being maintained inside the net house that were later tested serologically following the NCM ELISA protocol of the International Potato Center. Serological assay is the test being used for now, but hopefully we will be able to do very soon the RT-PCR as we still lack some lab supplies. Based on serological assay, the 10 viruses were detected in all survey sites, affecting all sweet potato varieties, including those that do not express any symptom. This characteristic of virus diseases in sweet potato, where infected plants are asymptomatic, makes the selection of planting materials complicated, hence the need to really enhance the production process, establish a functional seed system for sweet potato, and regulate the distribution of the planting materials. Optimization of SPCPM production protocol involves enhancement of processes within the production flow with the addition of molecular assay and the use of the indicator plant Ipomea setosa and improvement of the micropropagation process. In this biological assay, symptoms of the sample plants, whether they exhibit symptoms or not, will express the symptoms of the disease. This is necessary since most sweet potato viruses are asymptomatic. ELISA tests, particularly the use of nitrocellulose membrane or NCM, has its limitations since the number of viruses it can detect depends on the anti-sera that are available. So far, we can access only 10 that are available for distribution by the International Potato Center. Another limitation is its subjectivity on the identification based on the intensity of coloration because this is done for visual examination. Hence, we will likewise be shifting or migrating to the use of microtiter plates in the serological assay. As I have mentioned, there are already 30 viruses that have been reported to attack sweet potato worldwide. Subjecting the samples that we collect to molecular assay may result to detection of more viruses attacking the crop in the Philippines. So the primers of these 30 viruses were synthesized for use in this project. The production process is outlined in a simpler presentation in this slide. Storage fruits of 12 varieties from apparently healthy-looking plants were collected as explants for disease cleanup and were subjected to thermotherapy. This include the 4 major varieties being widely cultivated in the region: Taiwan, Quineros, Nube, and VSP6, along with NSIC 35, 30, 25, 24, 17, the Super Ube, Rosella, and Japonita, and 5 fingers. These are colored varieties, the orange, purple, and yellow, and these are subjected to participatory field performance and sensory evaluation as we intend to introduce this for commercial planting in the lahar and lowland rain-fed areas in the provinces of Tarlac and Zambales to cater to the needs of the industry. Polyphasic detection of viruses will be done involving biological, serological, and molecular assay. We have been multiplying indicator plants for bioassay of mother plants from meristem culture, since a number of Ipomea setosa seedlings are needed for grafting with mother plants to determine the symptoms that will be expressed if ever infected with viruses. This is necessary since most sweet potato virus infections are asymptomatic. Serological assay for ELISA is done, then molecular assay through RT-PCR. Multiplication for tissue culture is done to plantlets that were found to have no evidence of virus infection in the free indexing procedures. Micropropagation of the VSP6 sweet potato variety is done continuously while initiating the micropropagation of other varieties. Outplanting is done in small plastic pots containing sterile media inside the net house. The plantlets or mother plants are acclimatized for 2 weeks before these are planted inside the net house and further propagated following the rapid multiplication technique or single node cutting technique. The Mayantok SPCPM producers cooperative that were trained on SPCPM propagation sourced out their mother plants or C1 stem cuttings from the Tarlac Agricultural University for further propagation in modified net houses then in multiplier farms. Non-traditional sweet potato farms where virus diseases have not been detected are considered for multiplier farms. The net houses and multiplier farms can be applied for accreditation by the Bureau of Plant Industry, and planting materials produced from this will be certified clean planting materials upon passing the inspection standards set in the circular issued by the Secretary of Agriculture, which was one of the outputs of our past project funded by Picard, the guidelines for certification of sweet potato planting materials. Administrative Circular Number 4, Series of 2013, that was signed by then Secretary Alcala. Farmers are trained to propagate this clean planting materials so that the quality will be maintained until it reaches the commercial sweet potato farms. Members of the Mayantok Sweet Potato Clean Planting Material Producers Cooperative started engaging in SPCPM production after undergoing several trainings related to this project. I would like to emphasize that there is demand for SPCPM, that SPCPM production in itself is an enterprise, that one cooperative, the Mayantok SPCPM Producers Cooperative, is engaged in SPCPM production and is supplying the planting material requirements of sweet potato farmers not only in Tarlac but also in nearby provinces, like the program of the Department of Agriculture. The cooperative has established their market in the province and other sweet potato growing provinces in the region. The production, however, is not enough to supply the demand of SP growers even for the province alone. That is why there is a need to intensify the production by involving other cooperatives like the Binukawan Bicol Marketing Cooperative of Bagak Bataan, FLOPA of Florida Blanca in Pampanga, and the Sapang Multipurpose Cooperative of Moncada Tarlac to push through with their initiative to commercialize SPCPM. The fact that they have undergone trainings related to SPCPM production. Additional players in the production of SPCPM will greatly move the sweet potato industry in the region. Tracking the distribution and utilization of SPCPM produced by the center and the cooperative is one of the concerns of the project to determine the performance of the planting materials until these are planted in farmers' fields. Because of reported problems due to unregulated distribution of planting materials, we engage the services of the Bureau of Plant Industry that has the mandate to accredit nurseries and certify planting materials for distribution. The virtual training on nursery accreditation and plant material certification conducted recently is the first ever training conducted for sweet potato, and this is an initial step toward regulating the commercial distribution of certified clean planting materials. With this, farmers are now assured of planting certified good quality planting materials. At this point, I would like to thank the Department of Science and Technology for the funding, Picard for the technical support, and TAU for the administrative support. Thank you.
Thank you, Dr. Laranang. Our participants are now excited for the Q&A portion. But before that, we still have our third speaker who will enlighten us about the new technologies on Eggplant. Once again, you may leave your questions or comments in the comment section in this FB Live post. Just write to whom your question is addressed as well as your affiliation before posting your question. At the end of this webinar, we will be flashing the link to our Customer Satisfaction Feedback Form or CSF. All participants who accomplish the CSF will be issued with an e-certificate. Only those who submitted their CSF will be given the certificate, so please make sure to accomplish our CSF form after this webinar. We will not post the link to the comment section as Facebook does not allow posting of links during live broadcasts. The link, however, will also be posted in the comment section later after the live broadcast. Those who were not able to watch this webinar live may still submit the CSF until 12 midnight today to be entitled for an e-certificate. Please give us 10 working days to process the issuance and distribution of the e-certificate as we have a lot of attendees in today's webinar. In accomplishing the CSF, kindly make sure that you input correctly your complete name as you would want them indicated in the certificate. Likewise, please make sure that you input your email address correctly as we will be sending out your e-certificate via your registered email. Again, the link will be posted later during the closing program. Sa mga participants na may mga katanungan po o komento, paki-click lamang po ang ating StreamYard link para makita namin ang inyong pangalan at saang institusyon kayo nabibilang. Now moving on, our third speaker is an associate professor of the Institute of Computer Science of the University of the Philippines, Los Baños. He obtained his PhD in computer science in 2018, and his primary interests are on image processing, computer vision, and artificial intelligence. He is currently working on 3 IT projects, specifically on Eggplant, identification of Philippine wood species, and lightweight image processing tools for coral reefs. Ladies and gentlemen, it is my privilege to introduce to you our third speaker, Dr. Val Randolf Madrid.
Hello, JN. Thank
Hi,
you
Sir
for having
Val.
me here. It's
Kumusta po?
fine and very sunny here now in UPLB.
Hi, sir. If I may ask po, can you share with us how you got involved in this eggplant
Dr.
research?
Hautea contacted me way back in 2018, and I have attended seminars about eggplant, and I've learned that eggplants are really interesting because they're very, very versatile in terms of cooking it in a variety of dishes. And you don't need a large area to be able to harvest a lot of eggplants.
Thank you, Sir Val. Bago po natin i-flash ang presentation ninyo, magbibigay po muna ako ng mga trivia sa ating mga viewers ngayon o participants. Alam nyo ba na ang pinag-aaralan ng team ni Dr. Madrid at ni Dr. Hautea ay ang insekto na nagdudulot ng 80 to 90% na losses sa ating eggplant. At alam nyo ba na according to DOST FNRI, ang eggplant ay pangatlo sa mga gulay na kinakain nating mga Pilipino. At ang heaviest na eggplant according sa ating Guinness World of Guinness records ay ano? Guinness Book of World Records ay 3.6 pounds ang bigat, kaya sobrang bigat ng eggplant na yon. Sige sir, our viewers will know more about this research na inyo pong na inyo pong sinasagawa sa inyong presentation. Take it away, sir.
Okay, good afternoon again, viewers. In my talk, I will be showing you how my two friends, computer vision and machine learning, have joined the Eggplant Phenotyping Party. So sit back and I hope you enjoy my talk. Take it away, JN.
Good day. My name is Val Randolf M. Madrid, and I am a faculty at the Institute of Computer Science in UP Los Baños. I'm here to talk about cost-effective, computing-based phenotyping tools for eggplant research. First, I would like to thank Dr. Desiree Hautea of IPB for allowing me and my research team to work with them in this project. What I will present to you today are updates for the study, development of IT-based phenotyping apps. I have to admit that when I first became a part of the eggplant research project, much of the science concerning eggplants was new to me. I still don't understand most of it, to be honest, but I will share with you the aspects of eggplant research that have piqued my interest as a computer scientist. Computational complexity is one of the things that make computer science different from other math-based disciplines. It is studying the behavior of an algorithm or a solution as you increase the input. Eggplant production can be viewed as a computational problem in which we study the behavior of eggplant production as a function of certain management approaches, such as pest control, particularly for the eggplant fruit and shoot borer, or the EFSB, and the leaf hopper. Computer science is also about managing complexities in order to see a solution's potential. We can see here that a properly managed eggplant farm can have a lot of potential for the average farmer. Computational complexity can also be applied to phenotyping. In fact, this is our team's part in the project. In a workshop on eggplant characterization, our team learned what the process is like for field researchers. It was clear that phenotyping can get very complex very fast. Imagine doing eggplant characterization times the number of accessions times the number of eggplant varieties that you want to study. The complexity quickly shoots up, mostly in terms of time, effort, and energy. We need to manage the complexity of this problem in order to help researchers. The advantages of applying computing solutions to phenotyping are: first, it speeds things up by letting the machine do all the repetitive and mundane tasks. It also helps lessen the errors. As humans get tired, they make mistakes. Third, it helps the scientist focus on the thinking and problem solving. And it also frees up the scientist to do other tasks such as multitasking. So why go cost effective? Well, we all know that in government, budget and procurement are always a challenge. For computing, there are two aspects that can be made cost effective: hardware and software. Computing devices nowadays are cheap and plentiful. Before, laptops used to be a sign of luxury, but now everybody has one. In terms of hardware capabilities, the computing power of today's tech is way powerful. According to this particular article, the computing power of this iPhone is 32,000 times more than all the tech in this room, which is the NASA control center that sent people to the moon and back in 1969. So the iPhone's computing power can send people to the moon and back and let you post your TikTok video at the same time. Software libraries today have made it easier to build computer vision and machine learning applications. Since phenotyping will require a scientist to keep his mind active and eyes open, we can replace this with computer vision programs that use cameras and artificial intelligence, or AI, for knowledge building and data processing. Some of these software libraries are Open Computer Vision, or OpenCV, TensorFlow and Keras for AI modeling, Python as the programming language. Tesseract is another computer vision library for optical character reading, or OCR, and Numerical Python for fast processing. Here are some of the prototypes we have developed for phenotyping eggplants. We use the term prototype because these software are always being improved. I'll share with you what we have done for the first two, which are the main scope of our work in the project: the eggplant fruit and shoot borer preference test using video tracking and automated trichome density counting from images. In the pipeline are also other prototypes focused on making the task of phenotyping a lot easier. We were not able to gather enough multispectral sample images for the last one in development because COVID took over when we were about to gather drone image data. Our main study is using cameras to record videos of EFSB larvae as they go around different eggplant slices in order to determine feeding preference. Instead of researchers watching and observing for hours, cameras can just record, analyze, and you have results. You can have a very simple setup depending on what tools you have. A box, EFSB larvae, eggplant, and off-the-shelf webcam and laptop, or just a mobile phone connected to a laptop via Wi-Fi. Your task is just to record a video as long as the camera view is top view. Once that is done, you can now use the program. We have devised a simple command line based Python program that will help analyze the video. It is powered by a YOLO tracker, or the You Only Look Once tracker. It is an AI model that allows us to track the movement of the worms in the video. From what you can see here, the program would divide the view into regions. This can be customized. This way, you can place different eggplant varieties in different parts of the view to distinguish them from each other, and then the AI would recognize the moving objects as worms and track their movements, especially the regions and the slices they visited. But the process program usually has a lower frame rate than the video input, as you can see here also in the difference of the two videos. There are two types of output in the program. The first is a log output. It's simply a text file that records the events that happen in the video. If you look at here, this means that at the 23 to 24 second mark on the video, EFSB larvae were found lurking in regions 4 and 7, implying that the eggplant slices in these regions are being targeted. A second output is simply a trajectory image, which shows the direction and the movement of the worms throughout the video. It could be used for further analysis. This one here is our automated trichome density counting program. It uses an image processing algorithm to count crown or heads or trichomes. All you have to do is upload the images into the program. Around 68 to 75 accuracy was seen due to the image quality and limited dataset. We are currently improving this by incorporating deep learning neural networks. Tech isn't always reliable, so we made a prototype to read data from written forms for easier encoding. We redesigned some of the forms so they will be machine readable. The output then of reader is a CSV file. Although this still leaves much to be desired, but it is a start. Another one of our prototypes is the italong, or using your mobile phone to do eggplant characterization. Leaf dimensions are the one that is still stored for now in this app, and it uses image processing algorithms. The error between actual and app measurements is about 2%. We did a paired t-test in this one. We are developing an AR core, or the augmented reality core based version of italong, so it can do actual measurements with just the phone as a ruler. It's very similar to Google's AR Measure and Apple's Measure app. After we have seen the results of our previous tech prototypes, we are now incorporating neural network architectures to further improve image recognition for better data gathering in phenotyping. So in conclusion, phenotyping is indeed tedious and time-consuming. But with today's powerful computing devices, there is a lot potential for a do-it-yourself, cost-effective computing solution. So don't hesitate to collaborate with tech people that you know to help you out. Thank you, and good day.
Thank you, Sir Val. Madami na po sa ating mga participants ang siguradong namangha sa ipinakita niyo po sa amin at sa pag-aaral na isinagawa ninyo at ng inyong team. Now, let us set the ball rolling for the much-awaited Q&A portion. The floor is now open for your questions. For the first question, it is addressed to Dr. Virgillo Gonzales and ito po ay tanong galing kay Mr. Ronald Buenaventura. Sir, ang tanong po niya ay saan daw po kaya siya makakabili ng tamarind seedlings o planting materials? Dr. Gonzales?
Good afternoon. Isa lang po ang ating available o accredited na source ng ating tamarind. Ito po yung ating seedling nursery sa Pampanga State Agricultural University. Yung kung interesado po kayo, may number po kami dito. Babasahin ko po dun sa kasi naibigay ko na yung answers dito sa ating chat. Pwede nyo pong tawagan o i-text itong 0955-844-3003 at pwede po kayo mag-email sa inyong lingkod, virgilio_gonzales@psau.edu.ph. Salamat po.
Thank you, Dr. Gonzales. Our second question is for Dr. Lilibeth Laranang. Ito po ay galing kay Miss Sherilyn Marquez. Ma'am, ang tanong po niya ay what is the most successful and effective way of managing the kulot disease of sweet potato? Dr. Beth?
Yes, so far, the most effective and successful method to control the disease is by using the clean planting materials. Kasi wala naman po tayong resistant variety that has been developed as of now, kundi yung paggamit po natin ng clean planting materials. Thank you po.
Thank you po, Dr. Beth. Our third question is for Sir Val. Sir, ito po ay galing kay Miss Grace Joy Villena at ang tanong po niya ay ano po ang maitutulong ng na-develop nyo na software sa ating mga farmers? Sir Val?
Well, technically, we are not helping the farmers directly, but we are helping the researchers who are helping the farmers. So we try to build and create phenotyping tools so that the researchers can be freed up from the task of doing the mundane aspect of phenotyping, like looking at every image, counting all the trichomes, or staring at the video for a long time to see which of the eggplant varieties were preferred by the EFSB larvae. So I hope that if the researchers can be freed up by the mundane tasks of phenotyping, then they can have a better time to think of better solutions on how to address the problem of pests in eggplant for the boon of the farmers. Thank you.
Thank you, Dr. Val. Our next question is from Mr. J. Vincent Malabanan and it is addressed kay Dr. Virgilio Gonzales. Sir, ang tanong po niya ay if I will venture into tamarind production, where can I sell my produce?
Well, pwede po kayong makipag-communicate dito sa aming tanggapan sa Tamarind Nicer. May mga database po kami ng aming mga market partners. Pero bibigyan ko po kayo ng halimbawa ng aming buyer o market. Ito pong Marigold Manufacturing Corporation. May number po siya. Kung may ballpen kayo o lapis or what, isulat nyo na lang. Ayan, 0917-827-5289. They are desperately in need of tamarind pods from October to December. Yun po ang kanilang processing months. And they could accommodate about 5,300 kilos of tamarind per day. Salamat po sa tanong.
Thank you po, Dr. Gonzales. Our next question is from Bernard Mulyeta and it is addressed to Dr. Laranang. Ma'am, ang tanong po niya ay, can we equate SPCPM to resistant varieties? And why? Can you share your insights po?
Yeah, we cannot equate SPCPM to resistant variety. Kasi ang SPCPM ay nilinis lang natin, tinanggal lang natin yung mga viruses. Na that once we plant it in the field at ito ay ma-expose sa mga halaman na may virus diseases na naman, lalo na kung naandyan yung mga insekto na nagtatransmit ng mga sakit na ito kagaya ng aphids and whiteflies, then itong CPM natin ay pwede na naman magkaroon ng sakit na kulot. So hindi po natin pwedeng i-equate yung dalawa. So reinfection can happen after the CPM has been exposed to infected plants. Thank you.
Thank you po, Dr. Beth. Ang sunod po nating katanungan ay galing kay Lloyd Bustillos at ang tanong po niya ay para kay Dr. Val Madrid. Sir, ang tanong po niya ay kailan po kaya lalabas ang software o application na na-develop po ninyo? Sir Val?
Well, we are still trying to improve it. We are getting rough results, but it's a start. Maybe around 3 to 6 months. As to we're still getting video data for EFSB to test the program that we have developed. So there are actually it's a different aspect to check the veracity of what the software outputs compared to what the human checks. So we have to get more data so we can now compare if using the software would be faster and more accurate compared to what to a human examiner. So maybe we'll just let you know once we're done. Thank you.
Thank you po, Dr. Val. Our next question is from Adrian Paul Dumalen. Dr. Gonzales, kayo po ang tinatanong niya at ang sabi po niya ay naapektuhan daw po ba ang sweetness ng tamarind sa uri ng lupang pinagtataniman nito?
Ang sagot ko dyan ay focus po tayo sa potassium. Pag mababaw, kulang po sa potassium ng lupa, nababawasan po ang kanyang katamisan. Ang mga puno ng sampalok, sweet tamarind, na tumutubo po dun sa mga lupa na mataas ang potassium o kaya inabonohan ng potassium fertilizer, ay nag-i-improve po at gumaganda po yung lasa in terms of sweetness. Thank you very much po sa tanong, Sir Dumalen.
Thank you po, Dr. Gonzales. Ang sunod po nating katanungan ay galing kay Dongkoy Tejamo. At tinatanong po niya si Dr. Laranang kung kailangan daw po bang mag-fertilize ng kamote at ano daw po kaya ang best soil texture para sa kamote para ma-maximize ang magagamit nila o ma-harvest nila sa kamote. Dr. Beth?
Yeah, salamat sa tanong na yan. Palagay ko, ang tanong na ito ay dahil sa pag-iisip ng mga tao na ang kamote ay tanim ng mga tamad. Ano po? Kaya lang, ang kamote po kagaya ng ibang halaman ay nangangailangan din ng abono. Kung ang halaman ay hindi natin abonohan, lagyan ng fertilizer, hindi din gaganda ang tubo nito. Sa tanong na kung ano ang best soil texture para sa kamote, kailangan natin po ay sandy loam ang soil natin upang ang kamote natin ay maganda ang kanyang yung texture, maganda ang tubo ng kanyang laman, hindi po yung uka-uka. Kagaya ng ng isang patalastas po noon na pag masikip ay talagang makakompact siya. So kailangan natin ng sandy loam type of soil at kailangan po natin bigyan ng abono upang tayo ay mabigyan din ng mas magandang laman, mas magandang ani. Thank you, Dongkoy Tejamo, for that question.
Thank you po, Dr. Beth. Our next question is from Karen Vicencio and it is addressed to Sir Val. Ang tanong po niya ay, Sir, base po sa preliminary test ng software na ginawa ninyo, nakita po nila sa pinresent ninyo na may mas pinupuntahan ang mga larva ng EFSB. Ano daw po kayang variety ito na nilalapitan ng mga EFSB at ginagamit daw po ba ito ng ating mga farmers? Sir Val?
Well, that's a tricky question. Our goal in our team is to create tools for the researcher. So actually, ang nag-design ng mga slices ay yung researcher. So hindi ko alam kung anong variety yon ang ginamit. But I know for a fact that the project that I am part of, sila Ma'am Hauteya are trying to look to as many varieties of eggplants to find the natural resistance to these pests. So most likely makakasama yung mga varieties na pinipili na ginagamit yung tinatanong ng mga farmers. So we're still bringing in more video data. So actually hindi kami nag-prepare ng setup. We're just trying to create a program that will be easily reusable by researchers to generate such data. So thank you for that question.
Thank you, Dr. Val. So our next question is for Dr. Virgillo Gonzales and ang nagtanong po ay si Albert Malinaw Pardilla and he is from General Santos Academy Incorporated. Ang tanong po niya, Dr. Gonzales, ay papaano po ang makaproduce ng tamarind at paano po makapag-produce ng tamarind na kayang makipagsabayan sa global market?
Sir, malawak yung tanong na yan. Anyway, ngayon po ang aming ginagawa ay we are pumipili po kami ng mga tamarind lines na pwedeng i-register as variety sa National Seed Industry Council. Pwede po tayong makipagsabayan kasi dito makikita natin yung mga napili namin, mga selections or lines ay base sa pamangailangan ng industriya. Tulad ng makapal yung balat, mataas ang porsyento ng pulp o yung pulp percentage sa bunga. Ay isa pa po, meron na kaming na-identify actually ng mga lahi tulad nung isa na nanggaling sa ibang bansa at saka po local dito na mahahaba na pwedeng makipagsabayan sa ating global market. Then may mga ginagawa po kami pag-aaral ngayon, yung tamang pamamaraan ng pagpuprune, kung anong buwan dapat siyang i-prune. Isa po yun. At isa pa yung pampapaliit po ng mga puno. Meron na po kami na-identify na interstock para lumiit yung puno at magiging synchronized ang flowering nila. Yung mga seedlings na may interstock po kasi ay yung bali dalawa yung dugtong niya na pumipigil para bumaba yung carbohydrates at mapuno ng carbohydrates yung flowering shoot para sabay-sabay silang mamulakla. Maraming pong salamat, Sir Albert Malinaw Pardilla. Thank you very much.
Thank you po, Dr. Gonzales. Okay, last question na po tayo. Ang last question po natin ay para kay Dr. Beth Laranang at ang nagtanong po ay si Keen Andrew Adalin. Ma'am, ang tanong po niya ay ano daw po kaya ang naging dahilan ng mataas na demand o pagtaas ng demand ng kamote sa Central Luzon? May mga ginawa po ba kayong promotion o advertising na naging dahilan ng pagtaas ng demand ng ating produkto na kamote?
Ay, salamat sa tanong na iyan. Ang kamote ay hindi na kasi yung tinatawag nating poor man's crop, ano? Na pag ikaw ay kumakain ng kamote, ikaw ay mababa. Hindi ikaw, mababa. Parang nahihiya sila pag kumakain ng kamote. Kaya lang ngayon kasi, nakita na ng mga tao ang potentials ng sweet potato. Potential for food, potential for feed. So, lately, I guess that was 2008, kami po ay nag-conduct ng isang study, isang project, na we promote yung kamote as food and as feed. So, the fact that kamote was recognized by the World Health Organization as a superfood, kasi this is packed with nutrients, na andyan yung mga vitamins, minerals, and then the fact that ang kamote has a low GI. Ibig sabihin, pwedeng kainin ng mga taong may diabetes. Another one is that it's packed with antioxidants. Meron tayo yung mga range na kamote, mataas ang kanilang beta-carotene. Beta-carotene is an antioxidant ng vitamin A. So, madaming mga bata ang nabubulag because of vitamin A deficiency. And then sa ngayon, madaming nagkaka-cancer. So, ang kamote kasi, whatever color it is, mataas ito sa dietary fiber. Ano yung dietary fiber? Yun yung naglilinis sa ating bituka, naglilinis sa colon. So dahil mataas ang dietary fiber ng kamote, ay na-prevent natin ang occurrence ng colon cancer. Okay, bago po pala makalimutan, may mga kamote tayo ng purple. Nasa ngayon, dumadami na sa market. Ang purple kamote ay mataas din ang antioxidant niya na anthocyanin. So, ito is also anti-cancer, antioxidant. So, sa ngayon, na-promote na po yung health benefits ng kamote. So, actually, ngayon, mas madami ang kumakain na mga na mas mayayaman, yung mga nakakaintindi ng mga health benefits ng kamote. So, apart from that, meron din tayo dun sa feed industry, yung kamote na hindi na nagagamit, it's not marketable dahil una, ito ay maliliit o kaya malaking-malaki. Ito po ay pinaprocess. Chinichip po nila, dinadry, and then kinukuha po ng San Miguel Corporation as a raw material for feed. So, ito po yung isa sa mga kadahilanan kung bakit ang kamote ay madami ng nagpapatronize, madami ng kumakain, madami na pong gamit, madami na pong mga tao na dito po kasi sa Moncada halimbawa, may isang co-op po tayo dito, the biggest cooperative in the Philippines engaged in sweet potato production and processing. Ito yung Sapang Multipurpose Cooperative. So sila yung sole distributor ng dried sweet potato chips to San Miguel Corporation. So they have a project that was financed by the World Bank. At sila ngayon, upang sa ganun ay mapadami nila ang kanilang production on the dried sweet potato chips. So, sabi ng San Miguel, napakalaki ng kanilang demand for sweet potato. Kung ganyan sana yung demand, ang kanilang naibibigay lang is just a tip of the finger. So, kaya yun po yung aming nanghihikayat po kami ng mga cooperatives or whatever group it is na sana mag-engage din to turn those non-marketable roots into something that is of benefit to the people, to the feed industry. So sana mapadami pa po ang mag-engage sa kamote production. Yun lang po. Ay, hindi yata na naghang
Thank you,
yata.
Dr. Beth. Thank you everyone for your questions. Again, sa mga hindi po nasagot na katanungan, we will try our best to answer them directly in the comment section. Before we move on to the next part of this activity, to our resource speakers, meron pa po ba kayong gustong sabihin sa ating mga participants? Let us start with Dr. Gonzales.
Well, unang-una ulit, nagpapasalamat ako sa Picard, pagbigay nyo ng pagkakataon na isiwalat at ilahad ang aming mga promotion activities sa Sampaloc. Ako po'y nagmumungkahi din sa ating DNR, sa mga Penro officers, na pwede po natin gawing reforestation species ang ating Tamarind dahil ito'y matibay sa tuyot, nakaka-adapted po sa marginal areas, so that we could have, benefit our community around the hillside, at saka po pangalawa ay makakatulong po tayo sa kalikasan. Yun lang po, at Aida, hihabol ko na rin po pala, isa po sa mga nakikita naming may potential, itong ating young leaves o yung leaf plus, yung talbos po ng Sampaloc. May mga kasama po kasi kami sa Arayat, mga farmer cooperators at saka sa Kabanatuan. May mga puno po sila na closely spaced, minsan 1 meter, 2 meters, na silaki lang po ng tao. Ang araw-araw po nilang kinukuhanan ng talbos, and yung farm gate price po niya kapag dry season ay medyo mataas, from 120 pesos to 200 pesos per kilo, at inilalagay sa mga net bags, 16 kilos per bundle. So yun lang po, at magandang hapon po. Maraming salamat po. Thank you very much.
Thank you po, Dr. Gonzales. Dr. Laranang, meron po ba kayong message sa ating mga participants?
Yeah, unang-una, gusto kong magpasalamat sa Picard for giving us this opportunity to present what we are doing here at Tarlac Agricultural University. Tayo po ay magtanim ng kamote. Kung gusto po natin na kumita ng malaki, madami pong nagiging milyonaryo na nagkakamote. Pag sinabi natin nangangamote, tayo po ay tumataas ang ating income. Tayo po ay kumain ng kamote dahil ang kamote ay isang superfood. Madami po tayong makukuha ng nutrients, madami pong health benefits po ito. So, ganun lang po. Salamat po sa inyo lahat sa pakikinig ninyo po sa present naming mga proyekto.
Thank you po, Dr. Laranang. Dr. Val, meron po ba kayong sasabihin o maipapayo sa ating mga participants ngayon?
Well, the pandemic really showed us what things are really important, and one of them is food. So we really need to help and assist our farmers in helping our food production go up. So with the potential of using computing as a tool to help agriculture, I would advise those who would, who are doing agriculture work to partner with your local universities or your local tech nerds to help you in building solutions, computing solutions or machine learning solutions in agricultural problems. Thank you.
All right. Thank you, Dr. Gonzales, Dr. Laranang, and Dr. Madrid. To our participants, I hope that you were able to get valuable learnings from our esteemed speakers. I also hope that you will continue supporting our activities like this webinar. We had a very productive discussion this afternoon. To give us the synthesis of today's webinar, I would like to call on our commodity specialist for Tamarind, Ms. Maria Cecilia S. Alaban. Cel?
Sorry for that. Thank you, JN, and hello, everyone. We just heard interesting talks on eggplant, sweet potato, and tamarind. Now let me give you a summary of what was presented by our R&D partners from PSAU, TAU, and UPLB. The first topic delivered by Dr. Gonzales are initial outputs of the NICER Tamarind R&D Center. He highlighted the potential of tamarind as a resilient crop and as a crop with high potential in the processing industry. It is processed into tamarind powder, a popular flavoring ingredient or pampalasa among Filipinos. For this product, there are criteria set by processing companies as part of quality assurance. We also knew the morphological differences between the two tamarind varieties, the sour and the sweet. Further, it should be considered that a manipis na balat or thin shell is ideal for unripe pods intended for processing. This is applicable for the sour variety. On the other hand, it is important for ripe tamarind fruits, usually the sweet variety, to have thick shell to avoid breakage. Dr. Gonzales also mentioned the potential of biocontrol agents such as trichoderma in managing diseases affecting tamarind. Interestingly, we also learned that harvesting cost increases as the height of a tree increases. And so, among the efforts of the Tamarind R&D Center is to reduce these costs by applying S&T interventions to reduce tree height. On sweet potato, Central Luzon is the largest commercial sweet potato producing area. Among the commercial products are dried sweet potato chips, which is now a multi-million peso industry, and the fresh sweet potato processed into fries and gluten-free flour. The incidence, however, of the sweet potato virus disease complex and other pests has remained a problem of the sweet potato production in Central Luzon. There is also scarcity of good quality planting materials, resulting in decline in productivity of the crop. With these, Dr. Laranang underscored the impact of clean planting materials and optimizing production of sweet potato to meet its increasing demand. The establishment of the NICER Sweet Potato R&D Center in TAU enabled them to survey and identify the different viruses attacking sweet potato, optimize the protocol and production of clean planting materials to include molecular tools, and conduct tracer study on distribution and utilization of clean planting materials. It was also notable that farmer groups were engaged in the program as beneficiaries of the clean planting materials. Lastly, the importance of computer science as an innovative tool in phenotyping eggplant was highlighted by Dr. Val Madrid. Specifically, a computer program which utilizes algorithm was designed and developed by UPLB to count eggplant trichomes and document larval movement of the eggplant fruit and shoot borer, a damaging insect pest of eggplant. It was emphasized that the use of computing technology is time and cost efficient, fast, and more accurate than human phenotyping. The said technology will hasten research on identifying eggplant resistance against the eggplant fruit and shoot borer. The technologies featured today on varietal improvement, crop improvement, and propagation are all toward increasing crop productivity and supporting the industry development for tamarind, sweet potato, and eggplant. These projects are all ongoing projects being funded by DOST and DOST Picard. During the question and answer, among the questions asked was the source of tamarind planting materials, wherein according to Dr. Gonzales, these can be bought from PSAU. The contact details of PSAU was also provided by Dr. Gonzales. There was also a question on what is the most successful and effective way of managing the kulot disease of sweet potato. Dr. Beth answered that the most effective way is to use clean planting materials. One more question on sweet potato is if we can equate sweet potato clean planting materials to resistant variety, and the answer is no. Another question for tamarind was if its sweetness is affected by the type of soil. With this, Dr. Gonzales answered that sweetness is affected by the amount of potassium in the soil. And lastly, the technology developed by UPLB showed promising results. That is why a question was asked if when will this be released. According to Dr. Val Madrid, they are still optimizing the technology and the technology is expected to be released in 3 to 6